Welcome to another Trig Tuesday video. In this video we're going to be talking about radians. So we're going to go all around the unit circle and figure out these radian measures. Alright, let's start here. If we make no turn at all, no rotation, we'll have 0 radians. But if we make one full rotation around the circle, we'll have 2 pi radians. Right? So if a full rotation is 2 pi radians, then how much is just half a rotation? Well, it'll just be half of 2 pi, which is just pi. Well, if half a rotation is pi, how much is just a quarter rotation? Well, it would just be half of pi. So up here we'll write pi over 2. And if a quarter rotation is pi over 2, then what's a quarter rotation after pi? It'll just be pi plus pi over 2. And that'll give us 3 pi over 2. Alright, that's probably the easy part, and you guys probably get that real quick. The next ones for inside the quadrants, we're going to take them in sets of 4. The first 4 we're going to look at are the ones that are closest to the x-axis. So we go to the x-axis and go up and down, it'll be the first line we hit. The second set we're going to look at are the ones that are right in the middle. So the one that's right in the middle in each quadrant. And then the last set we're going to look at are the ones that are closest to the y-axis. So if we go left and right on the y-axis, it's the one we hit first. We're going to look at them in sets of 4 because they're all related. So let's get started with the first set. Now remember, this one is the set that's closest to the y-axis, or sorry, closest to the x-axis. If we go up and down. The reason they're all related is that if you look at your degree measures, you can see that this is a 30-degree angle. And if we convert that into radians by multiplying it by pi over 180, we can see that this angle here in radians is pi over 6. The reason they're all related is because they all make a pi over 6 angle with the x-axis. So with the x-axis and the line for each of these, the x-axis and the line, they all make an angle of pi over 6. Another reason they're all related is because the denominator for all of them is pi over 6. So we already figured out the first one. We know that this measure here is going to be pi over 6. So let's move this one out the way. We know that that's pi over 6. Alright, well, we know that half a turn is pi, or in another way to say it is 6 pi over 6. And then this little piece here is pi over 6. So this is pi, but then we went back pi over 6. Then that must mean that this one is 6 pi over 6 minus pi over 6, which is 5 pi over 6. Alright, well, if half a turn is 6 pi over 6, and then we went another turn, another pi over 6, then this guy must be 6 pi over 6 plus pi over 6, and that gives us 7 pi over 6. Alright, well, if one full turn is 2 pi, also expressed as 12 pi over 6, and this guy here is going to bring us back pi over 6, then this guy, this angle, must be 12 pi over 6 minus pi over 6, and that's going to give us 11 pi over 6. Alright, not so bad. Let's look at the next set. The next set is the ones right in the middle. Now these are all related because if you look at your degrees, you'll know that it's a 45-degree angle, and if you convert it, you'll see that by multiplying it by pi over 180, you'll see that this angle here is pi over 4. Now the reason they're all related is because with the x-axis in this line, for all of these angles, they make pi over 4 radians. So we already know that this guy's going to be pi over 4 because we just converted it. Now let's think, if half a rotation is pi, or in other words 4 pi over 4, and this one is going to take us back pi over 4 radians, then this guy must just be 4 pi over 4 minus 4 pi, or sorry, pi over 4, and that's going to give us 3 pi over 4. Again, if a half a rotation is 4 pi over 4, and then we went pi over 4 more, then this one must be 4 pi over 4 plus pi over 4. And that's going to give us 5 pi over 4. You guys see a pattern here? And then if one full rotation is 2 pi, or in other words, 8 pi over 4, and then we go back pi over 4, then this guy must be 7 pi over 4. Alright, so that's those are the middle ones, the middle radians in each quadrant. Let's look at the last set. The last set is the ones that are closest to the y-axis. So if we go on the y-axis and go left and right, these are them. The reason these are all related is if we look at our degrees, we know that this one is going to be a 60-degree angle. And if we quickly convert it into radians by multiplying it by pi over 180, we get that this angle is pi over 3. And the reason they're all related is because with the x-axis and the line, just like all the rest, they make a pi over 3 radian measure for their angle. And also because their denominators are all 3. So we already figured this one out. We know that this one is pi over 3. And if half a turn is pi, or in other words 3 pi over 3, and then this angle here is going to bring us back pi over 3, then this guy just must be 3 pi over 3 minus pi over 3, and that's going to be 2 pi over 3. Alright, we know half a turn is 3 pi over 3, then we go an additional 3 pi over 3, so that this guy must be 4 pi over 3. Alright, and then lastly, a full turn is 2 pi, or in other words, 6 pi over 3. But then this angle is going to bring us back pi over 3. So then this guy must be 6 pi over 3 minus pi over 3, and that's going to be 5 pi over 3. Alright, so this isn't so bad, and hopefully by all that repetition you guys see a pattern. And you might have also noticed that I had, throughout this, I had a -1, +1, and a ×2 -1. And let's just look at the full unit circle now that we have all the measures filled out. The -1, +1, and the ×2 -1, that's like a quick rule to get the numerator. Because if you notice here, we have the 6, the 4, and the 3, right? But then notice the numerators here on this side. It's just one less than the denominator, right? One less than the denominator. Over here, all the numerators are one more than the denominator. And then in this quadrant, in the fourth quadrant, all the numerators are 2 times the denominator minus 1, right? So if you know that the ones closest to the x-axis are related, you know that the ones in the middle are related, they all have the same denominator, and then the ones closest to the y-axis are related, and they all have the same denominator, and you know these simple rules, you can quickly fill out the unit circle. So hopefully this video helps you guys, and good luck on your Trig Tuesdays.